Well, let's talk about biofuel. It's pretty cool stuff that's going to become much more commonplace as you go through life. So basically, the world has to transition away from fossil fuels. I mean, we have no choice. A, they're going to run out, and B, they're causing the atmosphere to become incredibly warm and causing all kinds of problems. So we will transition away from them. And right now, we're at that sort of early stages of the development of these non-fossil fuels. So basically, as we start moving towards wind, geothermal, nuclear, these are great resources that don't put carbon dioxide in the atmosphere. But the problem is, we still need to have vehicles that we still need things that can travel large distances: cars, trucks, trains, planes, ships. And so they are going to need some sort of high energy density storage of potential chemical energy. And so it turns out that these biofuels are doing batteries alone don't do it. Batteries are heavy. And so I don't think we'll ever have commercial battery powered airplanes or battery powered ships. It's just too much. The weight to energy ratio just isn't workable, and so instead, biofuels seem to be the way to go. So biofuels are renewable, carbon neutral alternative to fossil fuels. So what we mean by carbon neutral is that the amount of carbon dioxide they put into the air is equal to the amount of carbon dioxide is taken out of the air in order to make them, and so uh, they basically we can use them the way we use gasoline and diesel, but they're made out of plant matter, usually like corn or algae. And the advantage is they're part of what we call the fast carbon cycle. If you remember from the very beginning of the school, we talked about the fast cycle and the slow cycle. The fast cycle means is basically the photosynthetic cycle of the atmosphere. So plants take carbon dioxide out of the atmosphere. Things consume that plant matter and put it back into the atmosphere through respiration. It's the same thing, except instead of putting it into animals, we're putting it into our vehicles in the form of these things called biofuels. It's really similar to like burning wood, except that we're turning into a liquid fuel first that can be used in cars and other vehicles. And basically, what we're going to do is we're going to to basically cycle carbon through these fuels, so it's basically carbon neutral. There's two main biofuels that we are banking on here in our society. One is ethanol. This has come a long way. It's very well established in many countries, including the United States. It's mostly produced from food crops, though, from like corn, and we typically use it in cars. In America, it's almost impossible to buy gasoline that doesn't have this. And then there's biodiesel. Now, biodiesel is not as commonplace yet, but it has a lot of prospects of becoming much more so. And it's produced from lipids rather than starches and sugars. And it can be used cars, trains, planes, boats, or just to heat. So let's start with ethanol, because ethanol is the one that's really in wide use as things stand right now. So ethanol can be produced from any sugars or starches. Basically, ethanol is just the kind of alcohol people drink to get drunk. You know, it's what's in soju. Okay, it's what's in beer. So ethanol is made through fermentation of sugars and starches, and by using yeast or bacteria or some other biological or anaerobe to break it down. Now, the technology is really clearly established. People have been doing this for as long as there's humanity, pretty much. But what's happened is in recent years, they've gotten better at making it worthwhile. So when it first came out, the argument was that what's the point of switching to corn-based ethanol? Because if you look at the amount of energy it takes to grow the corn, like the fossil fuels needed to grow the corn, that in the end, you just had it was slightly more energy that you were getting from the corn than you got from the fossil fuels you put in there. So it really wasn't worth the effort. Like it was like maybe like 10%, 20% more energy than you put in the form of fossil fuel. So it's not really. It seemed almost like a boondoggle that was there to help people who grew corn, right? But over time, it gets better, and that's something we really need to keep in mind with environmental science. Is things in their infancy often are not particularly effective, but as time goes by, they become more so. And so, uh, currently, like as things stand now, just in the last 20 years, it's moved from being like maybe 20% to like 400%. In other words, like you get 2 to 4 times more energy out of the corn plants in terms of the ethanol they're producing than the amount of fossil fuel you had to put in to make that happen. So at that point, they're quite effective. So, in many countries, including the United States, most gasoline that you encounter on the roadside will say is called what we call E10. That means it's 10% ethanol. Some of them will be E15, so 15% ethanol. It's very hard to find E0 gasoline anymore. It almost always has it because it is fully dissolvable in the same uh, petroleum compounds that make up regular gasoline, octane, pentane, things like that. Now, newer vehicles have a thing called flexible fuel vehicles, so FFVs. And what's nice about these is they can burn a wide variety of ratios. So they basically have a sensor in them that can detect what the ratio of ethanol to gasoline is, and they adjust their compression and carburation and so on using a computer system so that whatever you put in, they're going to burn it correctly. So in that case, you can use up to E85. So that means you could have an almost purely um, biologically derived, fuel for your vehicle. So no, it's like it's almost completely carbon neutral at that point. So, so the thing is, though, most ethanol is produced with starches and sugars, but corn or potatoes, whatever. Okay, but the problem is that like the things that make starches and sugars are things that people like to eat. The things that animals like to eat. So you're taking cropland that should be feeding the world's population and using it to feed the world's cars instead, which it seems not a great idea. But people point out, look, there's lots of other things that plants make that we don't eat. And wouldn't it be great? So instead of taking the corn that we like to eat, what if we took the rest of the corn plant and made ethanol out of it? So the thing is, the other parts of plants have a lot of cellulose. Cellulose is just starches that get stitched together in these large macromolecules. And so they're difficult to break down. Remember, like we talked about how cattle are able to do that because they have those anaerobic bacteria in their front stomach that can break it down. So basically, engineers say, well, look, if those bacteria can do it, let's figure this out. So you can basically take things like stems, leaves, the leftover part of a crop that you're not using, and chop it up, and then use a process of either like a biochemical using enzymes or bacteria to help break it down, or you can use a thermochemical process where you use temperatures and other kind of catalysts. But basically, you can break it down and get the ethanol out of the cellulose but you have to break down the cellulose first. So it's a little bit less um, energy efficient in terms of the production of it. But the good news is that as we advance in this technology, we'll be able to take grass clippings, whatever, and we'll be able to turn it into fuel. And so this is progressing. It has a ways to go, but like other forms of alternative energy, it is going to continue to advance. Now, biodiesel is a little bit different. So, biodiesel, instead of being made from starches and sugars, it's made from lipids, from vegetable oils and animal fats. You can even make it out of recycled cooking oil. So, like when McDonald's throws away their French fry grease, instead of sending it to a landfill, they're sending it now to places where it's being turned into biodiesel. But most biodiesel right now is coming from algae farms. So like you see in this picture here. So you can make it out of just any algae really. So you can use like seaweed, like people eat here. You can use it to make biofuel. But in many places, they're taking wide open desert areas and they're setting up these farms where they're growing what are called microalgae, so single-celled algal organisms that don't have all the supportive tissues with the cellulose in it, and so it's just a lot easier to filter these things out. They grow really fast, they reproduce very rapidly, and you can easily like get their chemistry right because they're free floating. You can filter them out easily. You don't have to get rid of the cellulose. So that's how most biodiesel is not being produced. Now, biodiesel at this point is not nearly as available as ethanol as a biofuel, but it will become more so as we move forward. Hey, thanks for watching.